Okay, in this next section, we are going to be talking about three functions that I want to go over before we actually get into refactoring our application. And again, now that we've covered how functions are made up, okay, and what is a pure function versus an impure function, and also now that we have gone over what how to structure our functions so that we can compose them together eventually to make our application. The next thing we want to go over, it's a few operators that you might be familiar with, but there are a few that we're going to be using over and over again. So it's good to just review them, and then after that, we're going to go ahead and get into our the refactoring our application part of the course. Okay, so let's jump into our editor, and the first application. So I'm just going to make a collection here. Okay, now a few things. I'm going to say var, and then one. Let's just say var collection equals 1. Okay, so first of all, what is a collection? Okay, and a collection, we can say it's 1, 2, 3. So it's just a list of things, but it also can be, and this is a distinction we want to make, it can also be a collection of one thing, right? So that's the first thing. A lot of people, when they hear the word collection, they think a list of things, okay? But or a list, okay? Not in this case. In this case, we want to think of collection as anything, okay? It could be a collection of just one value, okay? It doesn't need to be a collection of more than one. And again, this is going to become important once we start developing our application. So that's the first thing. So let's actually create a bigger collection here. So of 5 numbers, and let's create a function called sum, okay? And now sum is going to take an x, and it's going to return that x plus 1. Okay, so this is a very simple function that we've covered before. And now what we're going to do is we're going to learn our first operator. So the first operator is going to become map. Okay, and the map operation goes like this. We can map over a collection, so iterate over a collection, and then and it's better just to show you than it is to so you can get an idea. And then what we're going to do is we're going to pass it the number sum and the function sum, and then let's console log what this is at the end. Okay, so let's collect this value in the result. Okay, and then let's console log out the result. Okay, and as you can see, we get a new collection back with the 2, the 3, the 4, the 5, and the 6. All right, so that's what map does. So map pretty much iterates over a collection, okay, and applies. This is usually called a projection function, this right here. So the first value that map takes in is a projection function, okay? In this case, our projection function is sum, okay? And a map, what it does is it runs an operation and returns for every value. It applies that operation to each value in the collection. So in this case, all we did was we incremented it by 1, okay? So instead of sum, maybe we call it increment. That'll be more descriptive, okay? So all we did in this function is we incremented it, but essentially map takes a projection function and then takes a collection. Now this map, it's a little different than the one we're going to be using, because remember, as we spoke about in our functional style of programming, instead of actually attaching or binding the map function to the collection, okay, what we want to do is we want to pass the collection in as a value. Okay, that way map is not tied. In this case, it's tied to the JavaScript array. So in the JavaScript array, there's a prototype method called map, okay? But in this case, what we want to do is we want to decouple that, okay? And we're going to be using a utility from one of the function libraries we'll be using, okay? But anyways, you get the idea of what map does. And that's the first operator that we really want to get our heads around, okay? And it's very simple. It just iterates over a list and applies an operation to it, a projection function that you pass to it. Okay, so the next function we're going to go over is the filter function, and let's see how that works. So we're going to create a function called isString, okay, and we're going to pass it a value, and then that function, what it's going to do, this is what we usually call a predicate function. It's going to return either true or false, or 1 or 2 values, usually binary. So, and then we're going to check the values against this function. So we're going to say return only the values, okay, that are type of, and then we're going to say value equals string, or string. Yeah. So only if the value passed in is equal to a string, do we want the return of those values, and then we're going to store them in a let's store them in a variable. So var result equals let's see here, collection dot filter, and then we're going to pass our predicate function into it. Okay, and then what we should see in the console now is just the high return back, and then the rest of the collection will be and let's console log it actually. Okay, here we go. And as we can see, the collection has been filtered down into just one value, and in this case it's just the value high is the only one that's actually a string. But if we return, let's see here, integer, or is it number in JavaScript? I think it's number. So there you go. Now the collection, if we add, if the value being passed into the filter function, so the filter function, very similar to the map operation, will go through each value in a collection, in a list, okay? And then it's going to apply the predicate function that we pass into it to each of the values. So in this case, we're asking, hey, is this value a number? Okay. And we're going to do that for each and every single value in the collection that we're iterating over. And then we're saying, hey, only return me the ones that this actually equals true for. So in this case, we get the collection back 1, 2, 4, 5, and the high is excluded. And then if we pass in the string value, then we actually get the opposite. We only get the high value back, and all the numbers are excluded from that. Okay, so that's the filter operation. Okay, and these are the main operators, and you'll see with the knowledge that we have so far of we're gonna put here reduce. With the knowledge that we have so far of function composition, function purity, and just a few operators, really the power that this gives us to create pretty complex applications. And most of the time with these tools in your tool belt, you'll be able to go into almost any of the programs you have and start refactoring them into a more functional style. So the last operation we're going to we're going to go over is called reduce. Okay, and reduce is very similar to map and filter in the sense that it goes over each item in an array or in a collection, and then so we're going to write a reducer right now, and then we pass the reducer function. So this one we're going to call sum, and sum takes x and y, and then what it returns is x plus y. Okay, x plus y. Okay, and then we're going to go over our collection. Okay, and then we're going to say reduce. So the collection, the reduce function takes the sum plus an initial value, and in this case we'll call the initial value 0. Okay, and then we're going to store it in a variable, and we'll console log that variable. Okay, and then let's just see what it does. Actually, let's take the high out of here, and let's put all numbers instead. Okay, so we can actually see it working properly. So now we get the 15. So what did the reduce function do? The reduce, again, very similar to map and filter, iterates over a collection. So it goes over each value in the collection. And in this case, okay, if we were to write it, let's actually, okay, see what's going on over here, because it's easier to explain. So this is usually called the accumulator, and this is called the current. And then let's console log this. Okay, and now what we're going to do is we're going to say accumulator and current. Okay, and then we're going to console log the result as well. Let's see here. What do we do? Return. Okay, yeah, we changed this variable. So accumulator and current. Perfect. And then here we go. So now what we see here, that the first time this function ran, the accumulator was 0, because this is the initial value we passed into it over here. Okay, and then the current value was 1. So 0 plus 1 is what becomes the new accumulator, and in this case will be 1. Okay, and then the current value in the collection at that point is 2. Okay, so 1 plus 2 is 3. So the next time around, okay, the accumulator has become 3, right? Because over here we're saying accumulator plus value, and it was 2, okay, plus 1. So that gives us a 3. And we are in the 3 iteration. We are in the in the 3 number now of our iteration. So 3 plus 3 actually is 4, okay? So then the accumulator becomes 6, okay, because 3 plus 3 is 6. Then we go to the current value that becomes actually 4. Okay, so 6 plus 4 makes our accumulator 10, and then plus 5 is 15, and we get a total back of 15 is the actual return value. Now, one thing that I want to emphasize with reduce, at the beginning when I was learning about reduce, I think it's very normal and very intuitive to think that it's actually reducing everything to one value. And in a sense, it is, okay? But remember what we spoke about collections, right? It doesn't have to reduce everything into one single value or scalar like we're seeing here in our value, okay? We can, for example, reduce it one to a collection. Okay, so if we return just one collection, that collection can actually include, any number of values. Okay, what it's saying essentially is that we're going to reduce the operation. Reduce takes an accumulator and a current value, and then it's going to perform an operation, and then it's going to return one value back. Okay, remember when we're learning about binary functions versus unary function. The reduce function it's a binary input and a unary output. Okay, so but just because it's a unary output does not mean it has to be just a scalar of 1. So it's not just the number 15, okay? We actually could return, for example, we can pass this as a value, and then over here what we're going to do is we're going to go the initial value, we're going to pass it with the list of 1, and that list is 0, okay? So the first time around the accumulator is going to be the an array with 0 on it, but then the next and the current is going to be the actual number 0, okay? So then what do we want to do with that? We want to say, hey, the accumulator, let's go accumulator 0, okay, because it's actually only going to have the index of 0, and then the current value, it's going to be one of our numbers in our array, okay? So now what it returned to us, okay, is the actual number inside a collection, inside an array, right? So we started with a number inside a collection, and we got back a collection with that number inside of it. And we actually could say accumulator, okay, and let's see here, accumulator. So whatever was in the array plus, actually, I don't want to do it there. That's the initial value. Sorry about that. So over here, we're going to leave this at 0. So what we're going to return is everything that was previously in the array. So whatever was there, return it. And then what we want to add to it is just the current value, okay? So now it gives us the full array, okay? Plus, you can see that although it's a reduction function, what we're doing is we're just attaching the previous value to it, and we're concatenating in a sense. And then our reduction function does not return just one value, but it returns the same thing we passed into it, okay? But I just wanted to emphasize the point that we just simply by the fact that we return one array, that is the equivalent of returning one single value. But inside that value, we do actually have a lot of other value, okay? And this one way that we can get around this idea that reduction is just simply reducing something into one, although that is true. Inside that one thing, it could be a list, and inside that list, there could be any number of values, okay? So that's very important to understand. And those are the 3 operators that pretty much we're gonna be working with, okay? Through our application. And again, you'll see how with just these 3 operators, we can perform pretty complex, and we can create pretty complex programs. And again, get away from the object-oriented style of programming, which is storing state in one place and then changing it and mutating it. And again, that can create a whole lot of bugs. And we can see how we can turn one of those programs into a functional program very simply with these operators.